These calculations use gravity as 10 meters per second squared. A ball is thrown upwards with a velocity of 30 meters per second. What is the displacement of the ball after 2 seconds? So here, they say the ball is thrown vertically, so that means it'll be thrown like this. And to figure out the distance in 2 seconds, after 2 seconds, we have to see at what velocity it is at 2 seconds. So, let's see. At the beginning would be 30. And then it would be 20. Then it would be 10. And then it would be 0. And this would be at 0 seconds. Just when we throw it would be 30 meters per second. 20 would be at 1 second. 10 would be at 2 seconds. And 0 would be at 3 seconds. And this is because we're going at 30 meters per second. And we're decelerating 10 meters per second each second. So then, since we see this, and now what we need is the 2 seconds, which would be 10, and the 0 seconds, which would be 0. So basically, we're gonna see what would be the mean of these two speeds. So what we do is 10 plus 30, which would be 40, and then we divide it by 2, and that would give us 20. But this is not the answer, because this is the average speed, but it's not the displacement. To get the displacement, we just got to multiply the speed of 20 times the time, which is 2, and that would just give us 40. So the answer would be 40 meters. A ball is dropped. What will be the velocity? Will its velocity be after 65 centimeters? So here we're also using again the 10 meters per second squared for gravity. And instead of asking us the distance, well, the displacement, they're giving it to us. And they aren't giving us time, but they're asking us for velocity, and that's all we need. Because we just need 4 or 5 things. They could give us initial velocity, which we write as u, final velocity, which is v, distance, which is s, and there's also acceleration, which is a, or time, t. Before here, we could see there was time, distance. Even though they don't tell us what it is, we have to figure it out, so we counted out if they told us. Initial velocity, which is u, and acceleration, which is a. Here, again, they tell us acceleration, which is the same as before, because they say it's dropped. They tell us distance here. They tell us initial velocity, because they say it's dropped, so it means that it started with 0 meters per second. And they tell us also, well, they don't tell us, they ask us for velocity, final velocity. So this is what we're looking for. And basically the only thing that they don't tell us and we can eliminate is time. So the way we would do this is with a formula, which is v squared equals u squared plus 2as. So since they ask us for velocity, we're lucky that it's already here, and all we have to do is then pass the square, but that we'll do later. So first, we have to see we have to replace it in this side. So what we would do is initial velocity is 0, so 0 squared is just 0, so we can just eliminate this part. And then 2as, basically that's just 2 times our acceleration, which would be 10 meters per second, times our distance, which is not 65 centimeters, it's 0.65, because all the formulas work with meters, not centimeters, so we have to change it by dividing by 100, so 0.65. And then we have to calculate this. 10 times 0.65 is 6.5, and that times 2 would be 13. Then we have to do the square root of 13, so that we can just ask the computer. And that will give us 3.605551275463999. But normally they will just ask you for 1 to 2 decimal places. So in the case they ask you for 2, you would just get the 5, round it up to 1, and say it's 3.61 meters per second. But since they say it's dropped here, we know that's not gonna be a positive. It's gonna be actually negative, so it would be negative 3.61 meters per second. A ball is thrown upwards with a velocity of 2 meters per second. After how many of 20 meters per second? After how many seconds will the ball return to its starting point? Well, this one's really easy, because if they tell us it starts with 20 meters per second, and at the beginning also 10 meters per second, and here, how we did, each second would just subtract 10 meters per second. So all we would have to do is subtract it until we get to 0. But that would be to its maximum height. So basically, we start with 20. We remove 1 second. We remove 10 because that would be 1 second. So that would be 10. And after 10, that would just leave us to 0. But this would not be our... This would be 0 seconds, 1 second, 2 seconds. But this one, the answer would not be 2 seconds, because this would be the ball going up. But then the ball has to also go down. And the way to go down is, since up and down will be the same thing, we just have to multiply times 2. So since here we just said that it was 2 seconds, we know that it has to be 2 times 2, which is simply just 4. And then we just put seconds, and that's it. Sketch a velocity time graph for a body starting from rest and accelerating at a constant rate to a final velocity of 25 meters per second in 10 seconds. Use the graph to find the distance traveled and the acceleration of the body. So this we would start by drawing the graph. So I'm going to get this, which makes it perfect. Then normally what we put down would be time, and up would be velocity. So let's say that our 25 meters per second in 10 seconds would be around here. Could be anywhere. So this would be 10 seconds and a speed of 25. And since it says it's going at a constant acceleration, so it's not going first faster and then accelerates at a slower rate, we have to draw that by the acceleration line being straight. So I'm going to get this straight line. And basically, now that we basically already have our straight line, the way to calculate acceleration and the distance. So acceleration is really easy. All you gotta do is the final velocity, 25, and then just divide it by the time. Now, if they told us that it started with a velocity, we would have to subtract that to the 25. But they tell us it starts from rest, so it's just divided by 10, and that's it. So this would give us an acceleration of 2.55 meters per second. because acceleration is in meters per second and not just meters per second. Then they tell us distance, and distance is really easy because distance, all you gotta do is the area, and the area of the triangles is just the base, which would be 10 because here we just said it, it's 10 times the height, which we just said that that's 25, so that would be 25, and then for a triangle you gotta divide it by 2, so 10 times 25 would be 250. And this we divide by 2, and that would give us 125. And so that would be 125 meters. And so here we would have the distance here, and here we would have the acceleration. Thanks for watching. Don't forget to subscribe and hit that bell.